Hello students. So this is our second video lesson on the same chapter motion in one dimension. So in the previous video we have learned what is uniform velocity and what is non-uniform velocities and what is the concept of motion. A object when it changes its position with respect to surrounding and with respect to time we consider that object is in motion. And similarly if that object is not moving from its position and with respect to surrounding or time, then we consider that object to be at rest. So in this video lesson we will see what is acceleration. That means when a body is moving with non-uniform velocity, that means the change in velocity is not same whether it is increasing or whether it is decreasing. So when the change in velocity is in increasing order, we say that the motion of an object is in accelerated motion. Similarly, if the velocity of that object is decreasing, then we consider that it is in retardation, that is negative acceleration. Okay, so the topic for today's video lesson is acceleration. Okay, it is defined as rate of change of velocity with respect to time. That is, acceleration is given by change in velocity by time taken. Okay, so acceleration, it is a vector quantity. Second SI unit of acceleration is meter per second square. Okay, so when you find velocity, what is the SI unit of velocity? That is meter per second, and time, that is second. This second will be coming in denominator, then it will become second square, therefore it is written as meter per second square. So you see, when the change in velocity is in increasing order, that is positive acceleration. Generally positive acceleration or acceleration, right? But when the change in velocity is in decreasing order, here, then that is negative acceleration or retardation. Okay, so you see, when there is a change in velocity, that object, it is in acceleration or retardation. But when we consider that the distance covered by that object per unit time in equal interval of time is same and it is in specified direction, we consider to be as uniform motion, means here uniform velocity. Similarly, if that car or a body, if it is not covering equal distances in equal interval of time, but that car is moving in a specified direction, still we say that object is in non-uniform motion, or that is non-uniform velocity. Okay, so this is the basic difference between positive acceleration and negative acceleration. So next we have uniform acceleration and non-uniform acceleration. You see, I have drawn here car. From initial position, when the car was at rest, from initial position to 1 hour, after 1 hour the speed of car is 20 km per hour. After 2 hours the speed of the car is 40 km per hour. After third hour, the speed attained by the car is 60 km per hour. You see, the change in velocity is equal, like 20 minus 0, that is 20, 40 minus 20, 20, 60 minus 40, 20. That means this shows that the change in velocity or change in speed is equal in equal interval of time. So we consider this one to be as uniform acceleration. A body is said to be having a uniform acceleration if its velocity changes by equal amount in equal interval of time. Same here, velocity is changing equally in equal interval of time. Similarly, if that car is not attaining same velocity, you see from 0 to 1 hour the velocity of that car was 20 km per hour. After second hour, velocity became 25 km per hour. After third hour, it is 40 km per hour. The change in velocity is not same. So here in this case we consider as non-uniform acceleration. Okay. So a body is said to be having a non-uniform acceleration if its velocity changes by unequal amount in equal interval of time. Okay. So this was all about uniform acceleration and non-uniform acceleration. So the next topic we have here, equations of kinematic. Okay. So in my previous video lesson, I have told you that what is the difference between kinematic and dynamic. Kinematic is a branch of physics which deals with the motion of an object without undergoing its cause or without knowing its cause of that motion. Okay. But whereas dynamic is a branch of physics which deals with the study of motion with the cause causing it. Okay, with the cause that motion, how that motion has been formed. So this is the main difference between a dynamic and kinematic. So there are three equations or generally four equations of kinematic. First equation is that velocity time equation. Okay, v equals to u plus at. So this is the first equation, that is this equation is considered to be as velocity time equation. So what is v here? V means here final velocity. Okay, what is u here? Initial velocity. And a here acceleration. And t here time, right? So these are the terms which being used in this equation. Suppose a car is at rest, is at 0. So after some time the car has covered certain distance. Now at the initial position the speed was 0 because car is at rest, so we consider u as to be 0. So after covering some distance, if it is considered as 50 km per hour, then we will say that final velocity of that car is 50 km per hour. Okay. So this is the meaning of initial velocity and final velocity here. Next equation we have, this equation number 1, equation number 2, displacement time equation, or you can say relation. Okay, displacement time relation, that is s equals to ut plus half at square. Okay, where s is the displacement or the distance covered. Okay, you know that is initial velocity, t is time, and a is acceleration, and t is again time. So this is called displacement time relation. Next we have velocity displacement relation. Velocity displacement relation says that v square minus u square equals to 2as. V square, that is final velocity, square of final velocity minus square of initial velocity equals to twice of acceleration and displacement. So this equation is also known as velocity displacement relation. Okay, so these are the three equations of kinematic. Fourth equation is said that distance covered by a body in nth second. Okay, so when I say what is the distance covered by a body in nth second, it is meant that s nth equals to u plus a by 2, that is 2n minus 1. So s nth equals to u plus a by 2 within the bracket 2n minus 1. So what is n? N is the nth second. So these are the four equations of kinematic which will be using in numericals. So these are the four equations. So the next topic we will have here graphical representation. Graphical representation of motion. So in form of graph, how we will show that what is the position of that object, what is the nature of that motion. So if I say a body at rest, so how will we show that the body is at rest or not? You see, suppose in x-axis I have plotted time and in y-axis I have plotted displacement, right? So this is x-axis and this is y-axis. So if you see, this is, let us consider 1 hour, 2 hour, 3 hour, 4 hour and 5 hour. This is 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer and 5 kilometer. So displacement is in kilometer and time is in hour, right? So if I draw a straight line, this shows that that object is not moving from its initial position. So it has initially it has covered 3 kilometer, then the motion is constant. You see the object movement is not there, so we will consider to be as not moving, that means object is stationary. Okay, similarly if I say here object is in uniform motion, object is at uniform motion means here this is time and this is displacement. Okay, displacement is in kilometer and time is in hour. 1 hour, 2 hour, 3 hour and 4 hour. 1 kilometer, 2 kilometer, 3 kilometer and 4 kilometer. You see uniform motion means here equal displacement in equal interval of time. That means in 1 hour it has covered 1 kilometer, in second hour it has covered 2 kilometer, in third hour it has covered third kilometer, that is 3 kilometer, and fourth hour it has covered 4 kilometer. So this displacement is equal with respect to time interval. So we consider to be as uniform motion. Similarly, if we have a graph of non-uniform motion, then it will be like exponential, right? See, this will be time axis That means if I consider this one to be as it is starting from 0, okay, it is starting from here 0, 1 hour, 2 hour, 3 hour and 4 hour, and here you see 1, 2, 3, 4, 6, 8. You see this change in displacement is not same. Displacement was in kilometer and time is in hour, right? You see in increasing time the displacement is not same, so we consider it to be as non-uniform motion. Okay, if a body is covering equal displacement in equal interval of time, we consider it to be as uniform motion. If an object is not covering equal displacement in equal interval of time, we consider to be as non-uniform motion or non-uniform velocity. Okay, so these are the graphs of a body when it is at rest, a uniform motion and non-uniform motion. So in the board you can see one question. We have to calculate velocity of a body which is at 4 meter initially, and after few time it has attained 8 meter, right? So you see we have to calculate the velocity of that object. So what is the time interval here? In the question it is given as 2 here, that means that is 2 seconds. Okay, we will be calculating its velocity. So first we will redraw this question. So x-axis we have time, that is in second, and y-axis we have displacement, that is calculated in meter. Now the object was moving from 4 meter and the final displacement of that object is 8 meter, right? So as we have to calculate the velocity, we have to calculate the slope of this line. Slope can be easily found out by A, this is B and this is C, and you will mark this terminal as B. So as we have to find here velocity equals to displacement of that object by time taken. Okay, so what is the displacement? You see displacement is from D to B. This is the displacement, that is displacement is BD, and what is the time? Time is AD, right? This is the time taken and this is the displacement. Now BD can be written as total from here to here, total distance is BC minus total distance, if you subtract CD then you will get BD, right? Total is how much? Here BC, and from C to D if you subtract this one then you will get BD, that means BC minus CD, total divided by AD. So how much is BC here total? Total is 8 minus how much is CD? That is from 0, that is 4, and time interval is AD. AD is here how much? You consider here 2, that is 2 seconds. So our time is 4 by 2, that is 2 meter per second. Okay, so this is our velocity of a body which is moving from A to B. So BC minus CD equals to BD, right? So there will be a condition when an object is falling freely due to Earth's gravitational pull. If a body is at a certain height and if it is left freely, then it will fall due to Earth's gravitational pull, and the velocity will be increasing in equal rate. So this acceleration attained by that body due to Earth's gravitational pull is called acceleration due to gravity. So this is the acceleration of a freely falling body we consider to be as g. It is denoted by g and its value is 9.8 meter per second square. Okay, sometimes approximately it is also taken 10 meter per second square. So this is the acceleration by which a body falls from a certain height due to Earth's gravitational pull. So in fact all object which is falling due to Earth's gravitational pull will be having same rate of acceleration, that is 9.8 meter per second square, in the absence of air. But due to presence of air, so there are the two forces acting on that object. There first will be your air resistance and second will be the upthrust due to which that object will retard in motion, that means retard in backward direction. So an opposing force will act on that body and the velocity will get changed. Okay, so this was acceleration due to gravity whose value is 9.8 meter per second square. So on the board you can see one question. Here we have to calculate the speed of a body. So distance of a body is given 20 meter and time is also given 4 seconds. So what is the speed of a body which is found to cover a distance of 20 meter in 4 seconds? So we have to calculate here is speed. Okay. Here distance is given 20 meter and time is given 4 seconds. We know speed is equal to distance by time. This is just basic numerical which we have already solved in our previous classes. 20 by 4, that is 5 meter per second. So this is the speed of a body. So this is the second numerical. A point P is taken to be origin of time and position. 2 points Q and R are situated on a straight line passing through P. The position of Q and R are 8 meter and 12 meter respectively, while the instant at which body reaches these points are 3 seconds and 5 seconds. What is the speed of the body? So here you see in a graph, here it is plotted with respect to time in x-axis, that is in second, right, and the position that is plotted in y-axis. Let us consider the position or displacement is given in terms of s, or let it be speed only, or distance. Position means here distance, and origin is considered to be as P, because a point P is taken to be at origin of time and position. Okay, so this is position and this is time. In place of distance you can write position also, the meaning is same, right? So position and time. 2 points are given here in the question, that is Q and R. That Q is at a distance of 8 meter, that means here it is in 8 meter, and time attained by here, that is 3 seconds. Okay, the distance or the position of a body at point R is 12 meter, and the time is in 5 seconds. Okay, so this is given here. We have to calculate its speed. So we need to calculate the slope here, right? So in order to calculate its slope, you see speed equals to distance by time. So how much distance it has covered? You see, if I give you a name M, that means Rm by Qm, right? What is Rm here? That is 12 minus 8. That means from here to x-axis is 12, and from M to x-axis that is 8. So from 12, if I subtract 8, then we will be getting Rm. That means this distance is 12 minus 8. Okay, that is 4 meter. By qm, what is qm here? 5 minus 3, that is 4 by 2, that is 2 meter per second. Okay, so this is how we calculate the speed. So let me explain once more. You see, we have to calculate speed of a body. As the speed of a body we have to calculate here, we have to calculate rm here. Okay, so this rm can be calculated as total. If I give a name O, that means RO minus MO will give you RM. That is the distance covered by that object. Okay, that means RM, what I have done here, 12 minus 8. That what is 12 here? That is RO. And what is 8 here? That is MO. That means RO minus MO. That is RM. Okay. So here 4 by 2, that is 2 meter per second. So this is the third numerical. Light from our first door neighboring star reaches us in 4.5 years. That means here time is given 4.5 years. Okay, calculate its distance from Earth in kilometer. That means we have to calculate distance here. Velocity of light is 3 into 10 to the power 8 meter per second. That means speed or velocity, same here. That is given 3 into 10 to the power 8 meter per second, right? What is the speed of the body? Or here we have to calculate the distance, not the speed here. We have to calculate this. There is a misprint in the question. You see, calculate distance from the Earth in kilometer. Velocity of light is given 3 into 10 to the power 8 meter per second. Okay, so speed is also given. Time, we know speed is equal to distance by time, right? Or distance equals to speed into time. Speed, how much it is given here? You see, 3 into 10 to the power 8 meter per second into time. Time is given here 4.5. Okay, it is in year, and we know 1 year equals to 365 days. Again, 365, 1 day is 24 hours. So here 4.5 year, so 1 year can be written as 365 into 24, right? See, we have to calculate distance in kilometer, and this all terms, this is in meter per second. So how to convert in kilometer per hour? That is 18 by 5, right? See what we have done here, we have to calculate distance. Speed is already given, that is 3 into 10 to the power 8 meter per second, and time is given 4.5 year. So 4.5 I have written as it is, and year, 1 year equals to 365 days, 365, and 1 day we have 24 hours, so I have multiplied here with 24. Now this I have converted in hour, but still the speed is in meter per second, so we will be multiplying 18 by 5. I think you have not forgotten, when we convert 1 kilometer per hour to meter per second, we multiply by 5 by 18, and when we convert meter per second to kilometer per hour, we multiply by 18 by 5, right? So same way here, it is in meter per second, we are converting in kilometer per hour because we need answer in kilometer. So that is why we multiply 18 by 5. So we have to multiply all the terms, 3 into 4.5 into 365 into 24 into 18 into 10 to the power 8, total divided by 5, right? So this can be cancelled here. 5 1s are 5, 5 9s are 45, and this point we will get here, that is 0.9. Okay, so after one digit there is a point, so I have written after one digit, that is 9 point, that is 0.9, and we will be multiplying these terms. So this calculation we can do by calculator. All the terms we will multiply in a calculator, and you will be getting here 4 2 5 7 3 6 into 10 to the power 8, right? So this value you will be getting here. Now you see we have to place here point after first digit here. So how many digits are there? 1 2 3 4 5. After 5 digit you have to place here point. So what you will do, you will divide by 10 to the power 5, that is 5 zeros, and you will multiply by 5 zeros, right? So on doing so, you will be getting here 4 2 5 7 3 6 here point. This 5 zeros were there, so after 5 digits you will get point, and 10 to the power 8 plus 5. So 4.25736 into 10 to the power 13 kilometer, right? So you see here, after multiplication without the exponent term, what we have got 425736. So we need to place here point, we have to get its magnitude. So what is the order here? So order is here 5, that means divide by 5 zeros, 10 to the power 5, and multiply by 10 to the power 5. Now as bases are same, so I have directly added here, that means 8 plus 5, that is 13, right? So this is the total distance. So in the next class we will solve some more numerical questions, and this exercise questions you need to do as a homework. I will be giving a picture of this page also in your WhatsApp group, but you will be solving these very short answer questions. There are 22 questions here, and short answer questions, you see 14 questions. Okay, so these questions you will be solving in your exercise book, and you will let me know which questions you are not able to solve. In the previous class also I have given some questions to solve in your exercise book, but I did not get any feedback from your side. So you have to tell me which questions you are able to do, which questions you are feeling easy or hard. Okay, and you let me know your feedback.